Hello friends, today let's solve the burst blooms problem. Let's first see the statement. Given n blooms indexed from 0 to n minus 1, each bloom is planted with a number on it represented by array numbers. You are asked to burst all the blooms. If the you burst bloom I, you will get numbers left times numbers I times numbers right coins. Here left and right are agent index of I. After burns, the left and right then becomes agent. Find the maximum coins you can connect by bursting the blooms wisely. So let's first see the example. At the very beginning, we have the numbers 3, 1, 5, 8. Then we burst this one first. So currently, we have the 3 times 1 times 5 coins. Then our balloons becomes to the 3, 5, 8. Then we burst this 5. So we get 3 times 5 times 8. And now we only have the 3, 8 left. So this is 1, 3, 8. Because it said we can imagine numbers -1 and the numbers n equal to 1. So we can use 1 times 3 times 8, so on and so forth. So how to solve this problem? You can see this question has the optimal feature. So we may think about to use dynamic programming. And let's see this picture. As I said, we can imagine the numbers -1 equal to the numbers n equal to 1. So we can just new another array. The size just be the n plus 2. Assume the original array has a size of n. So now the array has the n plus 2. And we copy the original numbers value to the array A. And our problem is how to take use of the dynamic programming. Usually we use a 2D array to return the maximum coins. So maybe we can use of like DPIJ. But what does that represent? We can think to this DPIJ represents the max coins we can connect from the index I to index J. So like DP 4 means the max coins we can connect from the index 0 to index 4. But you see, we want to, because the simplest is that we only have the 3 coins, right? We just need to times them. Like the 3, 1, 5, the total coins we can connect is just use these 3 items product. So we can like use the bottom up. Let's see this example. First, we can just calculate the coins 3 by 3, like 1, 3, 1, and then 3, 1, 5. So then we want to calculate when the coins is 5, like 1, 3, 1, 5. As every time we just use 3 values to multiply. So when we make the left and the right solid, like left is this 1 and the right is this 5, we can pick this 3. So currently the coins we can get is 1 times 3 times 5. And use that to add the sub-problem, which is the DPI23. This is the max coins we can connect. Burst this from index 1 to index 3. And now we get the 30. the same. If we burst this one, so the coins we get by burst this one is 1 times 1 times 5. And the sub-problem is use that value to plus the dp0 to 2. And we already calculated before in this place. So the same, when we have 5 coins, we can choose, at the left is 1, 8 is, and the right is 8. So we can choose the middle index 1, 2, 3. In this case, we just calculate 1 times 3 times 8 and plus this 1, 2, 4. And this is the sub-problem we already calculated before. In this case, we just use 1 times 1 times 8 and times the and plus this dp0 to 2 and plus this dp2 to 4. And the same, we just get this max value represent to the dp left to right, means the maximum coins we can connect burst between the left index and right index. And finally, we just return dp0 to the length -1, which is the maximum coins we can connect between this 0 index to 0 length -1. So let's do it. First, we get n, which is the numbers dot length. And as I said, we want to use n plus 2. So we will new array, which is a, and the size will be the length. And we use the system array copy. The source array is numbers, start index is 0, and the destination array is a, and the start index is 1. The size will be n, and the a0 will be 1. The same a length -1 will also be 1. Then we will use a dp array. The size should be length. So dpij means the max value, max coins we can connect from the index I to index j. So we'll use the gap. Why? Because when we know the left index, we can just get the right index by the left index plus this gap equal to the right index. So the gap at first will equal to 2 because at least they have three items. So the gap will at least be 2. So the gap should less than the length, the gap plus. And for the left index, we start from 0. Left will less than the length minus gap. And the left plus. So the current, which means because we want to calculate, like this example, we want to calculate these 3 value and get the maximum value and assign them to the dp left to right. So we will let the current equal to 0. And we know the right index will be left plus the gap. And then we will choose the middle index, which you see it will be between the left index and the right index, like 1, 2, 3. So the I will equal to left plus 1, I less than right, I plus. So in this case, cur will equal to max cur and dp left I plus dp I is the sub-problems plus the current. If I burst, then it's left times a I times a right. So after this, we will assign this value to the dp left to right equal to the cur. Finally, we just return dp0 and the length -1. Okay. Thank you for watching. See you next time.